live?
We are going. Go for it.
All right. Fire it up here. All right. That's me. That's the course. That's where we're at. We already got into that a little bit earlier. Let's see.
Yeah, just point it towards this. Towards the Mac. You're good. Yep.
Jump a little bit. All right, digital signatures. By definition, a digital signature is a digital file that is attached to an email message or other electronic document. It is used to verify the document's origin and contents by means of associated encryption and encryption algorithms. The digital signature scheme basically consists of three algorithms. First, starting with the private key, which is what you kind of put the stamp on the digital signature when you're actually providing it. And the outputs the private key to the corresponding public key. The signing algorithm that's given a message in private key produces a signature. The signature then verifies the algorithm that, given a message, public key and signature either accepts or rejects the message claim to authenticity. Two main properties are required. First, a signature generated from a fixed message and a fixed private key should verify the authenticity of that message used by using corresponding public key. Secondly, it should be computationally feasible to generate a valid signature for a party without knowing that party's private key. This is basically a diagram of the process, starting with the document in the upper left. It shows that it generates through the hash algorithm, and then it is sent out by the private key of the user. And that's how the digital signature is applied to the document. And then upon receiving the document, it goes again through the hash algorithm to verify either or invalid or valid signatures. All right, this is basically a brief history on it here. With Phil Diffie, also Martin Hellman, around 1976 were the first to actually explain the idea of an electronic digital signature process. They're the first one that came up with the idea. In 1988, I'm probably going to butcher these names, Shafari Goldwater, Silvio McCauley, and Ronald Rivas actually took over the very first outline of the digital signatures and basically kind of set the standards for the use of digital signatures in the process. There we go. There's three standards of digital signatures. There's the RSA, which is actually named after the guys who developed the protocol. That's basically a basic standard of it. The DSA, which is the digital signature algorithm, which is the most commonly used one, and the ECDSA, which is an elliptic curve digital signature algorithm, and we'll get to these here right now. The DSA is computed using hash function and encrypted key, which is kind of similar to the first diagram we saw with the hash function, which basically sets this one kind of like a little different than the other infrastructures. So we'll have a numeric value based on the algorithm to alter the information. There's a little diagram of it. You can see the hash algorithms at the top, basically what they use to encode it and decode the messages upon the signature's arrival. And let's get to the next one. The RSA, named after Rivas, Shimari, and Alderman, is the most adopted use of digital signatures. It's basically, it's kind of like the grandfather. It outlines basically the whole thing. Now they're all based off of this one. So it's the first one made. It applies a private key and generates a signature to the document. Then the document is passed on, verified with the public key, determining if the document is valid or invalid. All right. And it's basically the three guys that created it up in the upper left. And as you can see, it's really basic, just involving keys, private and public, upon receiving and sending. An elliptic curve DSA is basically defined by a final set. It uses a private and public key as well. It relies on a set of domain parameters. And this set, a private key, public key, and domain parameters are all mathematically related to each other. The private key is also used for a limited amount of time known as the crypto period. But the public key can be used for a long period of time. It's defined by Dunning in an article I cited later. And this one, basically, the difference in this one, as you can see, the hash function is also matching the hash in the public key to fit the domain properties here on the bottom right. But other than that, it's pretty much the same standards as the RSA and the DSA we go by too. Okay. All right. This is what I mentioned cosign earlier in kind of the warm-up. It's basically one of the basic softwares that are used for digital signatures. It works with the following examples like Word, Excel, Outlook, PDF files, and many other integrated into. It basically integrates a digital signature into the document management and the workflow automation system of your choice, including SharePoint, OpenText, Oracle, and so on. It allows users to sign wherever and whenever they need to, whether the office, the PC, home, tablet, or the field, or in mobile device. You can see it's kind of being integrated into business throughout pretty much everything. Now here's an example of cosign, one of the softwares. As you can see, it can be embedded here in Word. We can see it up there at the top left. And the bottom part right here is actually an example of what a digital signature will look like. There's a check mark and an X that basically will approve the validation with the check mark, and a red X will make invalid or private key if any of the document has been altered. And one of the really interesting things about cosign that I didn't mention is if a document, say, requires more than one digital signature to it, the digital signature you see on this slide here only applies to everything above it. So if a second one comes around, everything below that document that requires it will fit into the second digital signature and so forth. Okay. And here is basically the last process of using a digital signature. Is upon when you sign something, like say for a company or anything like that, you'll be prompted a password, username and password to basically validate your signature. It's a final check safe in the, or final fail safe in the process, basically saying that you authenticate the document, and it's going to be password and encrypted using your private key through this process right here. Alright, and finally we're going to move on to the final benefits of using digital signatures. Basically it is secure and authentic documentation. It's effective means of approving documentations. In the business world, it's very cost effective for companies to implement opposed to the printing and filing system. Digital signatures is a green way of doing business, and basically you can very swiftly, very efficiently approve any documents you work for in a very fast amount of time. Alright, that concludes my presentation. Thank you guys very much. Any questions?
No question. Cost on cosign?
Cost on cosign software? That I do not know, but I
Roundabout, maybe?
can't imagine it would be anything more than $50, but honestly I have no idea on that one.
Alright.
But they do offer a trial version.
Okay.
If you go to arx.com, if you guys want to mess around with digital signatures, they have a trial software on their website you can download for free and kind of get maybe a 30-day trial to play with it if you guys are really interested in it too. So.
Cool. It's good to hear. Good job. Good job.
Thank you.
All right, number 2.